Yeah, hello guys. So today's Leetcode problem of the day. Let's straight away jump to the question, which is find the largest area of square inside two rectangles. Okay. So what that question says is there exist n rectangles in a 2D plane. Okay. For example, this is a 2D plane and there exist some number of rectangles which are n rectangles with edges parallel to x-axis. Okay, and y-axis. Okay, you are given two 2D integer arrays, bottom left, top right. Okay, so we have given two integer arrays. One name is bottom left, one name is top right, and what they stores is bottom left of I is a of I and b of I. Top right of I is c of I and d of I. Represents the bottom left and top right coordinates of the ith rectangle respectively. Okay, so what it says is, let's say this is bottom left, right? Ith rectangle means 0th rectangle, first rectangle, second rectangle. So for 0th rectangle, this bottom left contains is this. Okay, this bottom left for 0th rectangle, this is the bottom left corners, and corresponding 0th rectangle, this is the top right corners coordinate. So this one 3 3. Same way for first, this is the bottom left, this is the top corner, top right, and for third or second rectangle or third rectangle, we have 3 1 is our bottom left corner and 6 6 as our top right corners. Okay, so I hope you understood a bit of question. Now what it is asking is, you need to find the maximum area of a square that can fit inside the intersecting region of at least two rectangles. Return 0 if such a square does not exist. So what that basically is saying is, you have rectangles, okay, and these rectangles, they will be having some intersecting region, means they will be having some overlapping region. So in case of this rectangle, okay, this rectangle and this rectangle, they have this as a overlapping region. So we need to find the maximum area of square that can fit inside. So inside this overlapping region, what is the maximum area of square that can fit inside it? Okay, so if you understood, right? Same way, if we see this one and this rectangle have this area as common. So this, if you see, this complete is not an square, but how many squares you can fit? We can fit two squares. It can be having but one unit only. So maximum area will be 1 into 1 will be 1 only. So if you check any case, any overlapping region here, if you check any overlapping region here, we have 1 unit here. Okay, we have maximum 1 unit here. So we have output is 1 only. So a square with side length 1 can fit inside either the intersecting region of rectangles 0 and 1. Okay, 0 and 1. If we see, look, these two rectangles, we have this intersecting point, this overlapping region, which can give a square side of 1 each. How we are saying 1? Because if you see this length, this is 3x minus 1, here 2 means this is 1 unit and this also 1 unit. Hence and also 1 and 2, if you see this and this one, we have this region overlapping, but a square can be of this one only or this one. So maximum is 1 only answer. Okay, we'll see the other example also. So this example, if you see 1 1 is this left bottom corner, and for this one is 5 5 is the right top corner. So this is first, if you see, this one is our first rectangle or given in example. Now what is the maximum area we can get? So if you switch, second one is 1357, 1357. So this one is one rectangle. If you look into both these two rectangles, this one and this one, what is the common area? Common area is this one. Overlapping is this one. What is the area now? This is not a square, right? This is not a square. Yes, obviously, because this length is 5 minus 3 is 2, and this length is 5 horizontal. If we keep in horizontal 5, and here 1, this is 4. So now if you see, width is, height is 2 and width is 4. So this is a rectangle only, but how many squares we can fit inside it? If we take the minimum of both is 2. So if we keep this side also as a 2, this one is the area. So 2 cross 2 is the 4. 4 is the max area here. If you try any possible other rectangle also, we will get answer will be 4. This area, if we look at this example, output is coming as 1, because if you look any possible rectangle pairs, we have maximum square overlapping region is 1 only. So answer can be this one, but it will be maximum will be 1 only, 1 unit. So maximum sides can be 1 only, but 1 into 1 square means 1 square is, 1 into 1 is side square, means answer will be 1. This is our answer here. There can be a possible case where our coordinates does not even overlap our rectangles. So in this case we have to return the 0, because no overlapping area means we can't fit any square, right? So answer will be 0. No pair of rectangles intersect, hence the answer is 0. Constraint, if you look, bottom length, top right length are equals to n. N is greater than or less than 2, less than 10 to power 3. Bottom left I dot length, bottom right I dot length is 2 only, because we have x and y pairs only. Bottom left I0, say I1 is greater than 1, so always our will not be having this as our corner point or something. Will be always be having from 1, in both case 1 only. Minimum we can have 1. So here also 1 and and this one is bottom left I0, top right I0. This one is going to be less than this one is going to be less than this one, means this one is going to be less than this one, and this one is going to be less than this one, because we are representing bottom left represents the left corner and top right represents the top right corner. So obviously any coordinates, any of these xy will be greater than these xy. Okay, this is the simple condition, you don't have to worry about this. So I hope you understood the question now. So what is the first approach comes in your mind? So our approach comes in mind is, simple approach is, check all possible pairs of triangle, check all possible pairs of, not triangle, rectangle. Find the overlapping pairs, find the pairs which have some overlapping region, then only we will be able to fit some square. Region and then find the square region, return the maximum area. This is our simple approach which comes in our mind, and we will follow this only. So we will check all possible pairs of rectangle. How we can check? We can just iterate over this, and we will check this one with the, so if let's say we'll take this example, okay, 1 1 2 2 3 1 3 3 4 4 6 6, bottom left, top right. So this represents this one, these pairs represents rectangle 0, or you can say, you can start from rectangle 1, rectangle 2. So how we can check all possible rectangles? So what we can do is, we can start our I here, j here, we can check these two, then we can increment our j and we can check these two. Same way, then again we can increment our I and we can start our j here and we can check these two. Means this is a simple thing which we can do, which we will be doing. But the main part comes is, find the pair which have some overlapping region. Okay, we iterated on our rectangles, but now how we will find the overlapping region here? Okay. If you observe here, if you can find what is the conditions, what are the conditions in which our two rectangles will not overlap, okay, then remaining will be overlapping. So let's say we have these two, 1 1 3 3. This is one rectangle from here, and 2 2 4 4. This is our another rectangle, rectangle 0, rectangle 1, bottom left, top right. So in which case these two rectangles will not overlap? Okay, so if you see, observe clearly, if let's say if this left corner, bottom left corner is lesser than this one, here in this is lesser than both of these two, so this x also lesser than this x is lesser than, sorry, this y is lesser than this y, okay, and also this 2 is lesser than this one. If we see other way, okay, if we check with this rectangle, this 2 is lesser than this 3, this 2 is lesser than this 3. So but if any of case is greater than, if they are not lesser than, these both are not lesser than any of these two, let's say any one is greater, then what happens? See, if it's 1 1 3 3, okay, but if we change it as, let's say, 4 2 4 4, now this x becomes greater than this one. So if you try to plot it, 1 1, let's say this is 1 1, this is 3 3, 4 2 will be somewhere here, 4x means for this one, but y will be 2, so somewhere here 4 2, and 4 4 4 4 4 2 4 4, you can, means if you see 4 6, you can take 4 6 or something, so it will become like this. So in any of condition, if our this x, this y is lesser than, is greater than these x2, these x1 and y, it will be non-overlapping case. You can check, try by yourself also, take some examples, okay, we can check in this only. If we check these two, okay, so this one is sorry, this one is lesser than this one. This one is lesser than this one, correct? But this one is greater than this one. That's why it is going from this corner to here. It came in this space near. But if it has to be, if this 2 is greater than here, someone, let's say if we keep 1 here, then obviously this region will fall here somewhere. So what our conditions will be, let's say x dash y dash x, sorry, this, let's say w z dash dash. This is rectangle 1, this is rectangle 2, sorry 1, this is 0 1. So if any of, let's say our condition will be if this x is greater than w dash, or if this y is greater than z dash, this one. Okay, if any of 2, then this is not overlapping case. It will never overlap. Same way we have to check for this also. If w, here only we can write w is greater than x dash हो गया. Okay, or if z, this z is greater than y dash. So in this condition we will not be having non-overlapping case. So if it's a non-overlapping case, we no need to worry about it, because we will never find any square here. We can't fit any square here. Okay, in else case, then if we have some overlapping space, then what we have to do? Okay, what we have to do, how to check the conditions here. See, now we'll take a case and then I'll try to make you understand from that. Let's say we take this one. Let's say we have this case. One. Okay. Sorry, we can take this case. Okay. 1 3, or we can use this case also. Yeah, we'll use this case. What it is? 1 1 2 2 1 2. Okay. Bottom left is 1 1 2 2 1 2. Top right is 1 1 2 2 1 2. 1 1 2 2 1 2. Top right is 3 3 4 4 3 4. 3 3 4 4 3 4. Okay, so we know from here that all three are some in between, they are overlapping. So if we can consider these two triangles, let's say these two rectangles. Okay, 1 1 3 3 and 1 2 3 4, these pair of rectangles, to check if how much they are overlapping. So we know they are overlapping, right? We'll draw it once. 1 2 3 4 5. Same way we will draw this 1 2 3 4. Okay, rectangle first is 1 1. We have 1 1. Okay, and 3 3 is the top right, will be 3 3 here. 3 3. Other rectangle is 1 2 1 2. Sorry, 1 2 means here 1 2, and this one is 3 4. 3 4 is this one. 3 4. This is 3 3, sorry. So 3 4 will be here. 1 2, okay. 1 2 1 1 3 3 3 4 3 but 4, oh, sorry, this is wrong. 3 4 will be here somewhere. This is 3 4 3 4 here. So what is our first rectangle is this one, and our second rectangle is this one. This is 3 only. This is 3 4. Okay, let's say, so we have checked our non-overlapping condition, but if we comes under some overlapping case, then what will be the like how we will calculate our square and what will be the operations. Sorry. Then okay, so if you observe here properly, so this is our overlapping area. How we will find this area? This area is this minus this. So to find this overlapping area, we have to find this height, okay, and then this width. Cool. So how we will find this height? This height will be, if we have to take the minimum of both two. So if we take minimum of this one and this one, and height will be, to check the height we have to check this, means to check this height we need to take care of our y axis, y values. So 4 3. What is the minimum of 4 3? If you see, minimum of 4 3 is 3, and what is the to also, now we got this height, this is total till here, okay, but we have to get this one. So this one will be maximum of these two, okay. So maximum of this two and this one is 2, and then we minus, so we got this length, okay, and we got this length 2, and we got 3. The 3 minus 2 will be 2, this one. So we will be finding our this height. So 3 minus 2 will be 1, okay. So this way we can find our this we can find our this height, which is 3 minus 2 is equals to 1. Same way we need to find width. How we will find this width? If we drop these two, so again we will take minimum of these two from x-axis. No, yes, why minimum? Now you will be saying we already having 3 3. Let's suppose in some case, if instead of this coordinate we have our region here 2 4, then what we will do? Which height we need to take? So which width? We need to find this width, right? So we need to take this one, okay, we consider this one and this one, and we'll take minimum of these two, minimum of x of value. So 2 3, which one is 2? Minimum is 2, so we will get this 2 length. Now we have to remove this length to get this length, okay. If our coordinate is this one, then we have to find this is our overlapping area in that case. Then we need to take the maximum of these two, right? Here minimum of these two, so top corner are minimum of these two, so will be 3 2 means minimum is 2. And corners, let's say this left corner, this can be this side also, okay? So we have to take maximum. Let's say one corner is here, one corner is here, then we have to take maximum of these two so that we can go more this side, this way, okay? So we'll get the maximum of these two. Maximum of these two is in this case 1 is maximum, only 1 only, so we'll get this one, okay? Then this one and this one, this is, then this is our width, okay? So 2 minus 1 is 1. So our height and width is 1 1. So now this height and width came for, this height is 1, this width is 1. So just to make you understand, I took this. Otherwise, if we take the previous coordinate only, these ones only, our height, our width will come this one and our height will come this one, which is 2 and 1. So when we get our 2 and 1, let's say height is 2 came, width came 1. So now this is the overlapping area coordinate, overlapping area. But we need to find the square. So how can we make the square? So if we have height 2, width 1, so minimum of these two if we take, we can have 1. So we can have 1 as width also, 1 as height also, so to fit the area of 1. I hope you understood it, I guess. It's a bit tricky, you have to go through it once again if you did not understood, but I tried my best to make you understood the conditions. Once you get the condition, that is done. So just main focus should be to find the pairs which have some overlapping regions. So if no overlapping regions, we don't care about that. If some overlapping here, okay, we find the overlapping here, then we will find the height and width, then we find the square region. Square region will be the minimum of height and width. Minimum of height and width will be our side, square side, and then we can return the side square. So now how you will write the condition? Again, I'll walk you through code once again, and then you will be able to understood properly all this condition. So what we have to do is, we are just, this is normal, we are just calculating the length of number of rectangles so that we can write here simply. We can take the max side length in starting, our square side length is 0. Then we need to check with every possible pairs of rectangle. How we will check? We will start with I and j will be I plus 1, and we will check every possible rectangles. Now, so this is the case where we check is non-overlapping case. So if any of condition got true, it will be a non-overlapping case, and in that case we don't have to do anything, we will just continue. But if we found some overlapping region, some overlapping case, then in that case these two conditions to get the height and width. So again let me walk you through that. Let's say this one top corner and bottom corners, and other reason is, let's say this one. So we have this one as our overlapping region. So to find this one, we have to find this height, okay, and we have to find this width, right? This width and this height. Then only we can get to know what is the overlapping region. So for this overlapping region, this is the width, this is the height. How we will get this height? Height we will first take the minimum of these two corners, y coordinates, y, minimum of these two is y. So let's say x, y here, x and y here. So we'll take these two y's minimum. Okay, so here in this case we are taking minimum of top right, means top corners. First means y coordinate, y, y, we are taking minimum. So we will come here. So what is the y here? We'll get that. So this length we will get to know, complete length from, let's say this is our, so from y 0, y, this length we will get to know. Okay, cool. Now we will get to know this length. Now we have to find this, this length also, so that we can subtract from this one, we can subtract this one to get the this one. So how we will get this one is maximum of these two corners, max x y. So maximum of these two y's will be this length, sorry. So how we will get? So bottom left I first, bottom left j first, maximum. And if we minus from this to this, we will get this length. So this is our height. Same case in width also. So if you see width, this we have to find this one. This one will be this one, this point minus this point. So this length we can eradicate from this one. If this is total length, we have to minus, we will minus this length, then we will get to know this length, right? This width. So how we will get? So for this also, these two, out of these two will take minimum of x. So this top right I 0, x, both minimum will take, and from these two will take maximum of x. So 0 and 0 maximum will take, and then minus from here, minus here, this, let's say this minus this, we will get this length. So we'll get height and width in this way. Now our, to get the square side length, okay, so we are searching for maximum side square for square. So for this height and width we will take minimum. Okay, let's say height came 4, width came 2. So this can't make, this fully can't make the square, right? So only we can have a same height also with 2, such that we can make a square of 2 cross 2. That's why we will take minimum of these two, and we every time we will get the maximum. We will compare with the maximum length, and we will like collect the maximum side which we can get for square, and later we will return the area, max side length into max side length. We are doing this long because this can go to, this is integer, right? So this can go to out of bound. That's why we are converting it to long result, and we are returning this. I hope this I hope you understood this solution. This took little time and little bit long video, but my motive was to make you perfectly understand the solution or the approach. So if you see, the approach is this one only, which is your brute force approach. Check all possible pairs of rectangle, find the pairs which have some overlapping region, and then this, in that overlapping region, find the square region. One more thing here, you can just eradicate this condition also. No point of keeping this, you can directly keep this thing, because if you not keep this thing, when our like condition will go inside this non-overlapping case, this height and width will return some negative values. If you can try by yourself also, negative or positive, which never can be greater than 0, which are taken in starting only. So that will update to 0, and it will be like 0 only. Our area will come 0 in that case. So I hope you understood this solution. Just try it by yourself once, and you will be able to understand it fully. Thanks, and please like and subscribe if you understood. Thanks.